Listen, we're standing on the edge of what's probably the biggest tech shift since the smartphone. And trust me, it goes way, way beyond those passive little chatbots we're all used to tapping away at. Welcome to The Explainer. Today, we're diving deep into literally the biggest buzzword in tech right now, AI agents. So what actually makes a system an agent? And why is this completely flipping how we build software on its head? Let's just jump right in.
To kick things off, I want to challenge how you're probably thinking about AI right now. See, we're so used to AI being this passive conversationalist, right? Just trapped inside a chat interface. You ask a question, it spits out an answer, and then nothing. It just sits there, totally frozen, waiting for you to tell it what to do next. But what if it didn't just talk? What if it actually took action out there in the real world? Imagine handing a system a high-level goal, and it just goes off. It uses tools, double-checks its own work, and gets the job done totally on its own. That, right there, is the fundamental promise of an AI agent. Okay, let's dive into this. What exactly elevates a system from just a basic language model to a true AI agent? Well, at its core, an agent still has that text-generating brain, just like the models we already know and love. But the magic is really in what's wrapped around that core. This surrounding system gives it three massive superpowers that a plain model just doesn't have. First, the ability to take actions in the real world using tools. Second, the ability to observe the actual results of those actions. And third, and this is absolutely crucial, the ability to repeat this whole cycle. Act, observe, decide. Over and over again, completely autonomously. This is really the inciting incident for this whole technological shift. Think about your standard language model for a second. It gets some text, predicts the next text, and then, full stop. The loop is closed. It literally relies entirely on a human to keep the momentum going. But an AI agent, it completely flips that script. It takes an action, looks at what just happened, and then loops back around to figure out its next move, without ever waiting for you to type a single thing. It's essentially replacing your prompts with its own internal self-direction. It's a huge, game-changing leap from a system that just answers questions to a system that actively hunts down goals. So when you actually build this out into a functional process, you get what the industry calls the REACT pattern. That's R-E-A-C-T, short for reason and act. This is the secret sauce, guys. Here's how it plays out step by step. Step 1, reason. The agent literally thinks about the big picture goal and the current situation to decide, okay, what's my best next move? Step 2, act. Based on that thought process, it fires off a specific tool. Step 3, observe. The result of that action, maybe it's a web search result or even just an error message, gets fed right back into the system. And finally, step 4, repeat or stop. The agent looks at this new reality and decides, did I hit the goal? If yes, it stops. If no, it loops right back to step 1. Now, there's a really fascinating subtlety here about how an agent actually remembers things across all these bouncing steps. You'd probably assume the AI model itself is learning and remembering as it goes along, right? Actually, scratch that. Underneath it all, these models are fundamentally stateless. They have zero built-in memory from one step to the next. None. Instead, all of that memory lives in what we call the context window. The entire history of the task, the original goal, the reasoning, the actions, the results, every bit of it has to be carefully bundled up by the system and resent to the model on every single lap of the loop. And because these context windows have hard size limits, managing this memory without dropping the ball on important info is honestly one of the toughest engineering headaches in the entire space. Because of those exact limitations, an agent that's tackling anything more complex than a basic chore really has to plan ahead. It might use what we call upfront planning, basically drafting a full itinerary before taking a single step. Or it might go with interleaved planning, where it figures out just the next step or two and adapts on the fly as fresh info rolls in. And crucially, the absolute best agents out there use reflection. They explicitly pause to ask themselves, hey, did that last action actually do what I wanted it to do, before they plow ahead? Okay, we also need to clear up a pretty major misconception here. A lot of the confusion out there comes from people treating the word agent like it's a binary label, like assuming a system either is an agent or it totally isn't. But autonomy doesn't work like that. It's actually a spectrum, not just a simple on and off switch. There are vastly different degrees to which these systems can act and make calls without a human babysitting them. Think of it kind of like a journey. You start all the way on one side with no autonomy. That's your basic model that answers one question and then stops cold. Step up a level, and you've got bounded autonomy. Think of this as a workflow where a human lays down the tracks, but the AI is driving the train. Then you push further into high autonomy, and bam, you've got a genuine agent loop calling its own shots. The big takeaway here, as you slide up that scale, the more autonomy you grant, the more intense your engineering and safety guardrails absolutely have to be.
Let's zoom in on that far end of the spectrum for a second. Multi-agent systems. See, as a task gets incredibly complex, a single solo agent, even one with access to every tool under the sun, can get totally overwhelmed. It might lose focus or just start picking the wrong tools. The fix for this? Divide and conquer. You might spin up a specialized researcher agent that specifically digs up info, then passes its notes to a writer agent, which then hands things off to a reviewer agent. And usually the whole operation is managed by an orchestrator agent. Its only job is to break down the massive goal and delegate the pieces. This keeps every individual model's job narrow and actually doable, though I'll admit it definitely adds the headache of getting all these different agents to communicate smoothly with each other.
All right, I want to pump the brakes and slow things down for just a second here. Time for a bit of a reality check. We've spent this whole time talking about how amazing this conceptual loop sounds, but we really need to be honest about the immense, heavy-lifting engineering hurdles required to actually build these systems. Just as agents seem like absolute magic in theory, in practice, making them work reliably is a substantially harder problem than it first looks.
So, the crucial point here comes down to this brutal mathematical reality called error compounding. Imagine a single step in a really long task has a 95% chance of being totally correct. In isolation, that sounds fantastic, right? 95 is an A. But an agent might need to string together, say, 20 of those steps just to finish one goal, with each step directly depending on the one right before it. When you multiply that out, the probability that all 20 steps go perfectly drops off a cliff. A model that is impressively accurate on a single question can still completely derail a long task purely because tiny 20 errors compound over time.
And honestly, compounding errors are just the tip of the iceberg. You've got tool selection mistakes. The agent doesn't just have to decide to use the calendar tool, it has to perfectly book the exact right day. Then there's the notoriously tricky judgment call of knowing when to stop. You really have to prevent the agent from getting stuck in this endless, super expensive loop of just overthinking. And finally, the valuation is genuinely hard. For an open-ended task like, hey, go research this broad topic, there isn't just one single precise metric to definitively prove the agent did a good job. And if you can't easily grade the work, it's really hard to test and improve these systems. Which brings us to a very, very serious consideration, the blast radius of a mistake. We have to draw a hard line between read-only actions and write actions. If an agent is just gathering information or reading a file, the risk is pretty minimal, right? A mistake just means you get some bad text. But if that agent is authorized to send an email on your behalf, or delete a production file, or execute a financial transaction, the consequences are very real and sometimes totally irreversible. We're not just dealing with typos anymore, folks. We are dealing with actual real-world impact. Because of those incredibly high-stakes risks, no responsible developer on Earth just lets a fully autonomous system run wild. You absolutely have to build a rock-solid safety net around that core reasoning loop. We're talking strict permissioning, we're talking sandboxing, isolating the agent in a digital safe zone to contain any potential damage. And you need human-in-the-loop checkpoints, meaning no permanent, irreversible action happens without a real human being clicking yes. You also have to set hard limits on steps, time, and resources just to prevent those runaway loops we talked about. And all of this has to be backed by meticulous monitoring and logging so you have full auditability when things go sideways.
To wrap up our analysis today, let's contrast this whole new paradigm with traditional software automation just to highlight exactly what the trade-off is here. Traditional automation, like a script or a rules engine, follows a strict sequence of steps that a human hand-coded and fully predetermined way in advance. Every single decision was anticipated. AI agents, on the other hand, they're making real-time judgment calls based on reasoning over natural language and the actual messy results of their actions. It's a direct trade-off. Agents give you this incredible open-ended flexibility to handle stuff you never explicitly planned for. But you do sacrifice the perfect, boring predictability of traditional rigid code.
Which brings us to the core tension of this entire technological wave. As open-ended AI action scales up, and as these systems become more and more baked into our daily workflows, how much human oversight are we truly willing to trade away for automated convenience? We are stepping into a fascinating new era where software doesn't just sit around waiting for instructions. It actively hunts down goals. It's a hugely powerful shift, but one that demands really careful, deliberate design. Thank you so much for joining me for this explainer. I really hope this helps you navigate the wild and rapidly evolving world of AI agents.